morning, first hour. The reason I'm not in class today is because I am at a Kiwanis breakfast for the student of the month. So I'm not going to make it back before the end of first hour, but I will be here the rest of the day in case you have any questions. So feel free to stop by later on. Today is the 10th, and we are actually going to start chapter 10 today. So today we're going to look at 10-1. Chapter 10 is all about circles. So for today, we're just going to review some of the basics about circles. We're going to review that circumference formula that you guys have seen already this year. And then I'm going to show you some of the vocabulary words and so forth involved with circles. So let me draw a circle here. Whoa. There it is. And there we go. Okay, so first of all, I'm going to start out with the definition of a circle. We've looked at spheres already, so that would be like a ball, but a circle is defined as a set of points, kind of like a line is a set of points. So a circle is a set of points equidistant, so the same distance, equidistant from a given point. And that given point we refer to as the center. Okay? So a circle is not like a full disk, all right? It's just the set of points that go all the way around the edge that are all exactly the same distance from a given point, which we call a center, the center point. So all of these points, so this is really like hollow in here. There's nothing here. It's just the outside ring. It's not really a flat disk, okay? So here are a couple of things. First of all, I'm going to call this point E. When you name a circle, you name it according to its center. Okay? So to name a circle, I'm going to draw a little circle, kind of looks like an eyeball. And I'm going to call it circle E. So that's a symbol for circle. Like we have lines for, we have symbols for like angles and lines and things like that. That's a symbol for a circle. All right? Now, one of the parts of a circle you guys already know. So I'll maybe give that a J. That is the radius, of course. Okay. And a radius has an endpoint at the center and an endpoint on the circle. Okay, so here's the endpoint that's the center. Here's the endpoint that's on the circle. One of those points on that circle. All right. Another term that you're going to see today is what we call a chord. And that might look something like that. Okay. So a chord is spelled C-H-O-R-D, and a chord has both endpoints on the circle. Okay, so that's an example of a chord. You can draw those anywhere. So here is an endpoint on the circle, here is an endpoint on the circle for a chord. All right? The next one is actually like a special kind of chord. That is this chord. And you guys probably know this better as a diameter. Okay? And a diameter is just a special kind of chord. A diameter is just a chord that goes through the center. That's all. But it is still a chord because you'll see that the endpoints are on the circle. Okay, so these are all segments. So this radius, like, so if you're naming different things, which is what you're going to be asked to do today for part of it. So if I were to name a radius, I would say EJ and then put that segment symbol over the top of it. If I were to name this chord, like here, I'll call it B and C, I would name it BC and put the segment over the top of it. If I were to name this diameter, I don't know, how about HK? Okay, well again, I would go HK and then put that segment symbol over the top of it. So we haven't really done a lot with segments, you know, recently, but just to review that that's what that symbol is. So when you name all of these things, they are just segments. So make sure you put that segment over the top. All right, so that's going to be part of what you're going to be doing today, just identifying these things, so naming these things. So those types of problems you should be able to get through relatively quickly, I think. Then the other part of today takes a closer look at circumference. And we've already looked at circumference a little bit, because we had to when we were looking at like cylinders and cones and such. Okay, but this now we're going to focus more on circumference. So if you don't have it yet, you will after this. So just to review, the circumference is kind of like the perimeter of a circle. It's the distance around that circle. Okay? And there are two ways of looking at circumference. The way that we kind of looked at it was 2 pi r. The other way of looking at it, because technically 2 times r is really a diameter, you could say pi times the diameter as well, and they end up being the same thing. Okay, so let's see, I have 2 examples using circumference. So I can do them both on here. Here's the first one. This one we are going to work backwards. For this one, we want to find R and D if the circumference is 65.4 feet. Okay? So for this one, it doesn't, I mean, since we want to find R and D, it doesn't matter which one we start with. I typically use this one, so I'll start with that one. So 65.4 equals 2 pi times r. So for this one, if we want to figure out the r, we're going to have to divide by 2 pi. Just to remind you, put that in parentheses when you're dividing. So 65.4 divided by 2 pi would be about 10.4 for the radius. Now, to figure out the diameter, well, yeah, we could use the formula again, but really, isn't the diameter just 2 times the radius? So we take that 10.4 times 2, and we get 20.8 as the diameter. Okay? And I guess these would both be feet. Probably should put that label in there. All right, so you'll have some problems like that are maybe just a little bit more basic, where you're just kind of looking for the circumference, or you're maybe looking for the diameter or the radius. My second example is going to be a little bit more complex. This one we want to find the exact circumference of circle K. And there's circle K. It's a little lopsided, but there it is. And here's what we have for circle K. So we have a chord and 2 radii, and this chord is 3 times the square root of 2. Okay, remember, exact means you don't want any decimals. All right, so if we end up with like a fraction or we end up with a radical, we want to leave it like that. We don't want any decimals. Okay, well, let's think about this for a minute. No matter how many times you draw a radius, aren't they always going to be the same? Because they go from the center out, center out. So wouldn't this and this be the same. And I'm going to tell you that this is also a right angle. Okay, so I'm telling you that. So really, aren't we dealing with an isosceles right triangle or a 45, 45, 90 triangle? Why, yes, in fact we are. Okay, so in a 45, 45, 90 triangle, this is the n square root 2 side, this is the n side, this is the n side. So really, this is saying that n square root 2 equals 3 square root 2. So what do you suppose n is? That is correct. It is 3. Now we can find the circumference, because remember, that's what we want to find, is the circumference. Okay, so we got to plug in a 3 for the r. All right. Circumference equals 2 pi times 3. Now it said exact, right? So we don't want any decimals. So that means we're going to leave a pi in there. So really all we can do is multiply the 2 and the 3 to get 6 pi. That's the exact answer, okay? No decimals. It is exactly 6 pi. It's not approximately, 18 point something. Okay, so that's really what you're going to do. It was a short lesson today. So you're going to look at some different parts of a circle and identify those, and then you're going to do a little bit of work with circumference. And then tomorrow we'll look at a couple of other different things with circles. So hopefully I'll see you later on today. Otherwise, I will definitely see you in class tomorrow. Have a great day.